Welcome back, chemistry fans. I got 15 minutes before class starts, and you take the test. I'm going to see if I can solve these and get this all taken care of. So here we go. We're going to jump in with question number 1 from your exam. Let's do this. What is the molar mass? Now, what we must fundamentally remember is that's not a time symbol. That is an addition symbol. So I've got 2 manganese. They say down here at the bottom, roughly they are 55. So I'm just going to round these things up. You do not round up, but because I'm running out of time, I am going to round up. I've got 7 sulfurs. So I've got 55 times 2. I've got 7 sulfurs. They each weigh about 32. I've got 28 oxygens. They each weigh about 16. And then I have 5 of the waters, and they each weigh about 18. So I'm going to add all this together. 55 times 2 plus 7 times 32, the weight of the sulfurs, plus 28 times 16, the weight of the oxygens, plus 5 times 18, the weight of the waters, and 872 grams per mole should be your answer. All right, use sig figs, and we could talk about how many there should be in your answer with the values given to you. There are 4 sig figs with the H's. So you should have 4 sig figs in your answer. All right, moving to number 2. We're going from volume to atoms. This is a trick, and it's very, very key. So I'm going to have to do 7.95 times 10 to the 23 divided by the number of atoms. There are 2 atoms to turn this into molecules. So 7.95 exponent e to the 23rd divided by 2 gives me 3.975 times 10 to the 23 molecules. Now we can convert this into moles. Divide by Avogadro's number. And that gives me 0.660299 moles, which we then want to convert into liters, multiplying by 22.4. And we get 14.08. We need 3 sig figs, so 14.8 liters is my official answer there. All right, number 3. So we are going from grams to molecules. Nothing tricky about this one. 124.3 divided by the weight of carbon dioxide, it's going to be about 44. It doesn't, to me, it's 4 sig figs in my answer. So I'll be fine here with what I get. You'll get the approximate answer the same as I will. So I will have 2.825 moles. So that's grams to moles. And then I'm going to multiply this out into molecules, 6.02 times 10 to the 23rd. And I get 1.701 times 10 to the 24th molecules, not atoms, but molecules. All right, that takes care of that page. Moving on, let's go to question number 4. Question number 4 says for us to convert C2H2 into moles from molecules. So this is just a 1-step problem. So 4.56 times 10 to the 24th divided by 6.02 times 10 to the 23rd, that will turn us into moles. So it's just a 1-step problem. So 4.56 exponent e to the 24th divided by 6.02 exponent e to the 23rd, and I get 7.57 times 10 to the, no, it's just 7.57. Well, 3 sig figs, 3 sig figs in my answer. All right, moving on. Number 5, liters. 46.0 divided by 22.4 turns it into moles. So 46 divided by 22.4, that turns it into 2.05357 moles, but that's not what we're looking for. We're looking for grams. So we're going to convert this into grams based on the weight off the periodic table. Those C and O, they weigh about 28. So moles to grams, we're going to multiply our value times 2.05357. And I get 57.5. I have 3 sig figs. Grams is my answer. All right, question number 6. Question number 6. What's the mole ratio for this compound here? Well, there appears to just be one Va, but there seems to be need to understand that this distributes. So I'm going to have 2 of the N's and 4 of the oxygens. Okay, so that takes care of 6. We are moving on to question number 7. In question 7, we start to get a little bit more intricate. We're starting to talk about percentages. So I'm going to have to add up this entire weight of hydrogen, though, but we need all of the weights. So the platinum weighs 195. The chlorines each weigh 35.453, so I'll add those two in. 195 plus 35.5 times 2 plus 2 times the weight of the nitrogens plus 6 the weight of the hydrogens. All right, so plus 28 plus 6, and my total weight is somewhere right equal to 300. 299.9. We'll do the exact value. 299.9. Whatever the value is, it's close enough. We're going to have to take our 6 hydrogens, 0.0794, 1.008 is what it says here, and divide that by the 299.906, and let's see what our percentage of hydrogen is. And you get roughly 2%. With sig figs, it's 2.00. Since we have 4 sig figs, so it's 2.000%. All right, moving on. Number 8, empirical formula. So in this problem, what we need to do is take those percentages and turn them into grams. So 85.7 divided by the weight of iridium, and iridium weighs 192.217. The oxygen, 14.3 divided by 15.9994. So 85.7 divided by 192.217. I get 0.4458. 14.3 divided by 15.999. And these needed to be very, very accurate for us to come up with the correct answer. So we now take and we divide these by the smallest. 5.8. This equals 1.8938 divided by 0.4458, and you get 2. My formula is iridium 1, oxygen 2. All right, which pair is a complementary pair of molecule reduced down to its empirical formula? And here is your correct answer. This could be reduced down to divided by 15. You get 1 and 3. Oh, it's just that it's in the reverse order because it wants it to be molecular empirical formula. So just make sure that you're putting them in the correct order. That's the key here. So the 12 and the 48 could be reduced down, but it's again in the, this could be reduced down further. So that could be a 1 and a 4. And this is just in the wrong order. Okay. So that takes care of question number 9. Let's get to question number 10 and 11, our last 2 questions. Hopefully we can do it before class starts. We are up against it now. Have a few more moments left. I think we could still squeeze them in. Same process happens here, but this time I want the molecular formula because I'm giving you the weight. So I'm going to take my 45.27. I'm going to divide it by the weight of carbon that is given, 12.011. The 45.23 is for the oxygen divided by 15.999. And the 9.45 is divided by 1.008. Let's see what values we get. 45.27 divided by 12.011. 3.769, 45.23 divided by 15.999, 2.827, and 9.45 divided by 1.008, 9.375. Got to divide all of these by the smallest. So they'll all divide by 2.827. That comes out to be 3.769 divided by 2.827. I get Nope. 3.769 divided by 2.827, you get 1.33. That's where I was at. And then 9.375 divided by 2.827, and you get 3.316. All right, multiply these each by 3 would be the apparent obvious answer for me. And what I get is a 4, a 3, and a 10. So my answer is C4O3H10. All right, now what does that add up to be weight-wise? So let's do 4 times 12, because the weight of each one of these, we multiply it back, and we'll figure out what that weight is. 4 times 12 is 48, plus 16 times 3 is also 48, and then plus 10 more for the oxygen. So I got 48 plus 48 plus 10, 106. And it says that the weight is supposed to be 318. So 318 divided by 106 equals 3. My molecular formula is going to be 3 times what it is over there. So it'd be C12O9H30. That's my answer. Okay, one more question, and then we're done. And this one has to do with percent error, percent yield. So it says that in your experiment, your actual yield is this. That's the wrong value. And it says it should be 42.34. Calculate your percent error. So that would give me, sorry, a percent yield. So my correct value minus the wrong value. Either way, it's absolute value. Just subtract the 2 values on top and divide it by 42.34. Multiply that answer by 100. What you get is 22.69. Since all of these have 4 sig figs, that is my percentage. That's actually 70. All right. I worked all the problems for you. Hopefully you have a better understanding. Tell me what you didn't know. Tell me why you now understand it. Prove to me. Show your formula. Show all of your work. And don't just give me answers. Show me depth of knowledge here so that I can justify giving you back your full credit. Thank you so much for your time. Talk to you soon. Bye-bye.